Hi, I'm Justin Miller from Wowza Media Systems. I'm the video and webinar producer, and we are here with Barry Owen, the VP of Solutions Engineering. Barry, how's it going today?
Good. How you doing, Justin?
I'm doing okay. I brought you here to basically talk about streaming latency. I think you are one of our experts in the office.
Sure, I'll do my best. It's an ever-changing area for sure.
Very true, very true. So let's just start at the basics. How do you define what streaming latency is?
Well, latency is usually defined by, the amount of time the picture is captured on the camera till the amount of time the picture is viewed on the display of the consumer. So, we refer to that kind of as glass-to-glass latency, if you will.
Okay. And what generally causes latency from, let's say, the glass on the camera to seeing it played back?
Right. So there are many things that can really cause latency. So, the actual process of taking the video from a camera and then encoding it, and then you have to, whether you're encoding on the camera or whether you're encoding on a hardware encoder or software encoder, you have to transfer the video from one point to another over some sort of connection. Then once the video is encoded, it has to be then sometimes re-encoded or transcoded into different frame sizes, different bit rates, and then it's typically packaged into some format that you can deliver over the internet. And then, of course, you have to deliver it over the internet and actually get it from wherever you package that content, processed it, out to the user, who then has to get it into their browser, their phone, whatever, and then it's decoded and displayed. So, any one of those steps can cause various levels of delay.
I mean, if you look at it in terms of our streaming latency continuum, it seems like for cable television, there's a general latency of about 5 seconds, right? But when it comes to what we're talking about, say, generally streaming media online, we're looking at something between like a 1 second to even a 45-second latency. Now, why is that?
Broadcast industry has various levels of latency, and some of the reasons for that was for the ability to, do things like react to things for live events, so that if somebody says something you're not supposed to see, you can beep it, or things like that. They have a little bit of a window, and they can kind of tune their latency a little bit in a broadcast scenario. But you're right; it's typically 5 to 7 seconds, for a typical broadcast. With streaming, it varies greatly, and typically the way you think about it is, at that very low end of the latency spectrum, you can typically suffer from quality problems. You can suffer from viewer experience problems. It certainly will cost you more and more effort to deliver that at scale. So there are a bunch of trade-offs between, are you looking to do a one-to-one chat with somebody like FaceTime, which can be very low latency? Are you looking to stream the Super Bowl to 50 million people, which has a whole different set of challenges as far as driving the latency down at something like that?
And as I'm looking at our continuum, I mean there are quite a number of protocols you can choose from, depending on what your needs are. Let's take a look at the ones that are a little on the higher end of the latency spectrum, such as HLS and MPEG dash. Now, what exactly is the benefit of choosing one of these?
And I'll say they're on the higher end of the latency spectrum, at least for now. There's a lots changing in this area, but the the basic way that HTTP adaptive streaming works is that the content is encoded into chunks, right? And these chunks are usually, somewhere around 6-10 seconds long each. And the way that the players tend to play this stuff back is they wait till they have a chunk or two before they play, because they don't want to have to rebuffer. They want to keep their buffers full, and they know they can download the next chunk before they're finished playing the current chunk. So if you think about that 6 to 10 seconds, it typically translates, once you've added signal propagation and all those things into it, it typically translates into 20 to 40 seconds of overall latency. Now the upside of this is that with HTTP adaptive streaming, these chunks, and this is true for both HLS and Dash, they're very similar in many ways. These chunks are very easily cached at large scale for CDN delivery. And they don't have to have a streaming server to cache. They can be cached with, something, just a regular HTTP cache of sorts. So they're cheap and effective to leverage in a CDN. CDNs are really good at delivering chunks of data places. And, that allows me to create a very high quality, high scale experience. For something like an event with the Super Bowl, I can leverage a CDN and I can stream to 50 million people. And I can give them a relatively consistent experience with a high quality stream, probably giving them higher bit rates in general overall, and things like that. So that it's a very stable, higher quality viewer experience. Now the downside of that is, of course, is your second screen experience with streaming is now all of a sudden 20, 30 seconds behind broadcast. So you hear your neighbors screaming that something happened and you don't see it happening for another 20 seconds. It can be a little frustrating.
True, but is that necessarily important?
Well, it depends. So I will say that in general, people probably think they need lower latency than they probably really do, for OTT type applications, right? For large scale streaming, even event based streaming to a certain extent. But anytime you're trying to drive any sort of interactivity, or think about telemedicine, think about sports with gambling, think about just gaming, think about auctions. There's a ton of scenarios where you want a little more interactivity. Twitch has tried to drive their latency down and down and down. So it's really about your use case and how important that is to you. I mean, you can think of the cases in some of these things, like for a video conference, right? I mean, you need super low latency for a video conference, or it's very awkward.
Right.
FaceTime would be weird if it was a 10-second delay each time. A Zoom meeting would be very awkward if you have 10 people on and there's a 10-second delay, or the worst case, the delay is variable between them all. So there are many cases, even to reasonably large size audiences, where lower latency provides a better user experience.
Yeah, and I think in your actual example there, with let's say your neighbor screaming, and then you actually seeing the score occurring 20 seconds later, that's kind of fine if you're just at home, like enjoying the game. But if you're gambling, that 20 seconds is huge.
Yeah, that might matter, right? Well, and if you think about it, we once had a customer tell us, and this customer happened to stream dog races, right? And the lower the latency he got, the longer he could take bets on a race, the more money he made. Same thing with gambling, like live virtual gambling with card tables and things like that, right? The lower the latency, the more hands they get in a day, the more they make more money. So there's a lot of different drivers for this, some of which some people may not have really given a lot of thought to, but there's a place for all sorts of latencies within any given workflows.
Right. Well, certainly there are many people who do want as low latency or as real time as possible. I mean, just like for two-way communication like this, definitely low latency is important. But in some cases, certainly there isn't. There's an interactive experience, but it's not necessarily a two-way communication.
True.
In these cases, I mean, what streaming protocols do we really recommend for low latency?
So this is it's a fairly rapidly changing landscape. Finally starting to see some stability now that Apple has more or less finalized what they're going to do as far as a low latency version of HLS. We've had some specs and some implementations of low latency Dash for about 18 months now. So we're starting to see the ability to do lower latency at higher scale. But there's also still, what I'll call alternate protocols that are being fairly widely adopted. You have things like, WebRTC is typically used for, it started life as more of a one-to-one thing, but it's now used a lot for, few to few and even few to many kind of scenarios. And that'll typically get you 1 second or lower latency, and maybe as you scale out, it creeps up more into the twos. But it's very low latency. Certainly, SRT is an interesting one, particularly on the ingest side, to minimize your first mile time.
Mm-hmm.
There are some people developing SRT playback apps, typically on mobile, where it's interesting there as well. And then you get into the more broader things with low latency HLS, low latency dash. There's some nice commonalities emerging there as far as, both of them can use CMAF and things like that, which make them a little more CDN friendly, more efficient. So, I think you will start to see people getting in that 5 second range at higher and higher scales, where they still will want to leverage some of these other protocols and there's some proprietary protocols out there too, obviously, between, people using RTMP over WebSockets and things like that can get you into that 2 second range as well.
I feel like right now we're hearing a lot more about people they're looking at WebRTC. WebRTC is gaining a lot of traction these days, but as you've just said, we're just about locked in when it comes to low latency requirements for HLS. Right, that's right on the forefront there. Can you give me an idea of is there a difference where you would want to use, say, WebRTC versus low latency HLS?
Well, you will have, so most of the major CDNs are working on now supporting low latency HLS and low latency dash. So you're going to have a lot more choice as far as how you can deliver that at scale than you will with WebRTC. There are a handful of people doing WebRTC. I happen to believe that WebRTC will always be a little more expensive to scale. It requires effectively a session-based connection for each user on the edge, which means you need more hardware and more intelligence on the edge than you do with just an HTTP cache. So while WebRTC may drive the ultimate lowest latency, and if you're willing to put up with the downsides to that, including at least at this point, maybe a little less control over the quality than you would have with HLS or Dash. So there are trade-offs, and you probably overall, I still feel like the overall quality of experience for the viewer is right now a little lower with WebRTC than it is with that. But you do get lower latency. It's going to be very difficult for HLS or Dash to drive anywhere near that 1 second.
All right, fair enough. And in relation to all of this, certainly we should talk about how Wowza supports these technologies. Are we supporting both WebRTC and low latency HLS?
Yeah, so Wowza has been working very hard in enhancing, extending, and really just rebuilding and cleaning up our WebRTC stack over the last year. And right now, with the release of Streaming Engine 4.8.5, it's in a really good spot. So I think we really do now have a real first-class implementation of WebRTC. 4.8.5 also includes a version of low latency HLS. And, as we, and that version is up to, the current spec with Apple. If things change for the final release, and as we continue to work to getting this with our CDN partners, to getting that true end-to-end workflow go, I think it'll continue to improve there. And we will be supporting low latency Dash as well in the coming months.
Awesome. All right, Barry. Well, hey, thank you for chatting with me about this. I really do appreciate it. For anybody who is interested in learning more or who needs low latency for their live video streams, please check us out at Wowza.